Hello everyone. Today in this video we're gonna learn how to solve the second problem, teacher square. And this problem belongs to the website Codefox. So you can find this website by using this address codefox.com. Don't worry, you can access the link of the problem by my description here. In my problem description, I provide the link for you. This website is very famous because it's the place to practice coding skills and programming thinking for most of programmers around the world. So you can think that if you learn coding, you must know this website. And this website also provides a lot of contests. So every day you can find a contest by you click this button, contest, and you can see a lot of contests for you. You can access this contest if you want. Okay, you can register the contest, and it's free. You don't have to pay anything. The contest is very difficult and challenging. So consider to attend. And let's get back to our problem. So this problem called teacher square. And in this problem, we have a teacher square in the capital city of a country. And it has the size of n multiplied by n by m meters. Okay. And in the anniversary occasion of the city, they want to try to upgrade or try to maintain the teacher square they will cover the teacher square with the granite flagstones, and each flagstone is of the size of a by a, so it will be square flagstone a by a. Here, A and A. And we need to figure out what is the least number of flagstones we need to cover the teacher square. And the most important key you need to remember is we cannot break the flagstones. Alright, if you use a flagstone, you have to use on the flagstone. We cannot break down by divide the flagstone by two different parts. And the problem allows you to cover the cover space larger than the teacher square. So for example, if the square is n by n here, n by m, for example 6 by 6, I think I need to rewrite so you can look at it easily. Let me rewrite. Okay, for example, we have this 6 by 6 is 1, 2. Okay, so let's change the color so you can look at it easily. So our flagstone, for example, have the size of 4 by 4 in here. So because we can see each cell here represent 1 meter. So it's 4 by 4. So one flagstone can cover this here 4 by 4. 1, 2, 3, and 4 here. This is for the first flagstone. And next we have a remain 2 meters. So we need one more flagstone because we cannot break the flagstones. So we need to use on a flagstone. Okay, and then in the remain area we have 1, 2, 3. We have 1, 2, 3, 4. I made a mistake here. Let me fix this. Okay, so the flagstone have the size of 4 by 4. So it should be 1, 2, 3, and 4. You see that? 1, 2, 3, and 4. And then 4 here. And then we have remain 2 meters. But we need one more flagstone. Okay, and then we have remain 2 meters below. So we need one more flagstone. And for the rest area in here. So totally we have 4 flat stones. So I mean we need at least 4 flat stones to cover all the teacher square. Even though the area of 4 flat stone here is a little bit bigger than the real area, the actual area of the teacher square. Okay, so in here we have the problem. In here we have 2 cases. In the first case, so we need to figure out number of flat stone for the horizontal direction. And here we have 2 flat stones for the horizontal direction, and we need to figure out number of flat stone for the vertical direction. Okay, and then we can try to calculate the total flat stone we need just by multiply. For example, let's say it's k number of flat stones for the horizontal, and L is the number of flat stone for the vertical direction, and then the total flat stone will be equal to k multiplied by L. So how we can figure out k? We have 2 k's here. That is n, because the side of the theta square is n by m. So to figure out how many flat stones we need for the horizontal, we can using the formula n multiplied by a. Okay, and we have 2 cases. The first case is a divisible by n. So for example, if we have a equal to for example 3 and n equal to 6, so we only need 2 flat stones. And in the second case, the second case is a is not divisible by n. So it means we have a modular here different 0. So for example 7 divided by number 3. So we have the number 2 and remain 1. You see that? Or we can say in here, if we jump in this case, so how many flat stones we need to have? So you need to know that if you divide number b you divide a number a by a number b, so you have a remain c, and c always smaller than b. Yeah, of course. So for example, 7 divided by 3, we have a 2. You got number 2 here and remain 1. I mean remain here. Okay, the remain always smaller than number b here. I mean the remain area of this formula here always smaller than the actual area of a flat stone. It means if you jump in this case, so actually the total area for the horizontal will be equal to n divided by k and plus 1. Yeah, that's it. So that's actually the formula we need for the horizontal direction, and for the vertical it is exactly the same. So let's go to the implementation I prepare for you here. So in here, because the input they display not the input on the same line, so it's a little bit difficult for you to handle the input. So you should follow my instruction here to handle the input. So now you have n, m, and a. So we need to figure out the number of flat stones we need for the horizontal direction and for the vertical direction, and we need to check if a is divisible by n. So if not, we're gonna plus 1 more flat stone, and it's exactly the same for the remain direction. Okay, and finally we have the total flat stones equal to this formula as we have discussed. Okay, so that's it for the solution. We can try to run it. So for example, we enter 6 by 6 and 4. So the output must be number 4. And keep in mind that we should not provide any extra information here like what we have done before, because for example you can enter something here, so it's not good. Okay, try to avoid it, because we're gonna submit our solution to this website, so so we can make sure that our solution is correct. To do that, we need to go to the below website here. Let's go to the below and click this button in here. In here, I'm gonna select the solution for the problem, and then I click this button, submit. Okay, so that's it. I submit my solution to the website, and this website will try to test my solution. And if you get the accepted message here, so it means your solution is correct. If you have a logical error, it will show this message, wrong answer or test case. And if you want to know which test case you have got a wrong answer, you can click this button and scroll down, and you can see in here this test case. For example, the output of your code is 1.0, but the expected answer must be number 1, okay, without the float representation. Okay, and if you got a runtime error, this website will show you this message. Okay, and that's it for today. Hope to see you in next videos. Bye.